Welcome to the Chapter 11 Part 2 video. This video covers 11.4 and 11.5, where we will be talking about volume of prisms and cylinders. So our last video was about surface area, and if you'll remember, we folded those nets, so we can say that surface area really comes from a two-dimensional object. And so the big difference between surface area is that we can unfold surface area to be flat, two-dimensional. Volume fills up space. So volume is three-dimensional, meaning when we put units, they're going to be cubed. Okay, so the way to think of surface area is a covering over an object. Think about like painting walls. Okay, the way to think about volume is filling an object. So this is like a glass of water. So when I have walls that I'm painting, for example, I can have a room that's kind of cube shaped, and I'm just going to paint over those walls. That would be a surface area. If I'm filling up an object, and we'll just pretend to have a cube-shaped glass now, what is happening is I'm pouring liquid into that, and it's filling up with a liquid. And so we're going to fill up and fill up and fill up and fill up, and we're going to fill up all of that space. Whereas we were just painting the walls here, we're filling in all of the space here. So the volume is a different type of measurement than a surface area. So we're going to use these Legos, and I'm not super fond of this analogy because a Lego does have a height, but we're going to pretend that a Lego is flat. Okay, so think about a Lego as like a flat object, and if I wanted to find the area of a Lego, I could say this is 2 by 2. Okay, so remember, we're thinking about this as being flat, like a piece of paper, but it's a 2 by 2 piece. And so to find the area, we would say base times height or base times depth. I prefer to use depth here, so I'm going to change this. Base times depth, because we're going to use height for something else later. And so to find the area, it would be 2 times 2, which is 4. Again, thinking of that as a flat object, which means that now I can stack these objects on top of each other. So if I have 2 flat objects stacked on top of each other, and we'll use the same dimensions, base, and we'll call this depth so that we can call this a height of 2. I have 2 stacked on top of each other. And so the volume is the base times depth times height. Or sometimes we see length times width times height if we called this length and width. And so the volume is going to be 2 times 2 times 2. So whatever units this were, if it was 2 centimeters, 2 centimeters, 2 centimeters, then this would be 2 times 2 times 2, centimeters times centimeters times centimeters. So this is 8 cubic units, which means units to the third. So when we're measuring volume, we're raising our units to the third power. So in this one, now we have 1, 2, 3, 4, 5, 6 Legos stacked on top of each other, giving me a height of 6, still 2 by 2 for the base. And so we have 2 times 2, then times 6, or 4 times 6, giving us 24 units cubed. Okay, so our volume formula for volume is going to be base times height, where base, the capital B, means area of the base. Very similar to our formula for surface area, had that capital B for area of the base. So let's look at an example. Here we have a rectangular prism because it has 2 bases. I'm going to go ahead and color in my bases. I'll call this one and this one my base. So what are the shapes of the bases? Those are rectangles. Then how do I find the height? The height is the distance between those bases. And so my height is 3 meters. So now I want to find the area of the base. So we're going to draw this rectangle back out. It is a 4 by 12 meter rectangle. So capital B, area of the base, 4 times 12 equals 48 square meters. This is an area, so that's squared. To find the volume, I'm going to take that base and multiply it by the height. So that's 48 square meters times our height, which is 3 meters. And this shows us where that cubic meters comes in. And so we have 48 times 3, which gives us 144 cubic meters. That will be the volume. Let's try another. This time, instead of a rectangular prism, we have a triangular prism. So our bases are triangles. The height goes between the two bases. That's 22 centimeters. Our base is a triangle. Now be careful, we don't want to make any triangles right triangles that weren't already before. So this long leg, don't call it a hypotenuse because this does not have a right angle here. So the long leg is 49. Our left leg is 23, and the right leg is 35. They're all centimeters. But we also have the altitude of this triangle, which is 15 centimeters. So to find the area of this triangle, we're going to use 1/2 base times height from our area of polygons. 1/2. Our base and height have to be perpendicular to each other. So we can use 49 and 15. 1/2 times 49 times 15. Put that into the calculator. We should get 367.5 squared centimeters. To find the volume, I take that base and multiply it by height. 367.5 times my height of 22 leaves us with 8,085 cubic centimeters. That one's multiplication, that one is a decimal point. Okay. I'd like you to give this a try. Just try the first part here. Which triangular prism has a greater volume? Just try finding the volume of the one, and then we'll go over the second and the comparison together. So for this first one, we first need to find the base, which is the triangle. 8 and 3 are my base and height. Area of a triangle, 1/2 BH, 1/2 times 8 times 3, which is 12 squared centimeters. And then volume is base times height. That's the area of the base. So that's 12 times 12, which is 144. Volume is cubic centimeters. That's not our answer. What we want is we want to compare these. And so here we're given another triangular prism where this 6 centimeters represents the height. So again, we'll do base, which is 1/2 base times height. A base of 4 and a height of 6 gives us 12 centimeters for our area of the base there. And then the volume, which is base times height, our base area was 12 centimeters squared. Our height between the bases is also 12, leaving us 144 centimeters cubed. So which one has a greater volume? They have equal volumes. Okay, let's look at cylinders. We'll use a similar imagery as before, where we're stacking things in order to visualize volume. So remember, the volume is the amount of space inside a solid. So how much fluid could we fill the solid with, for example? And so if we're looking at a cylinder, our base is now a circle. So to find the area of a circle, we use pi r squared. Our radius is 7. That's pi times 7 squared, which is 49 pi. Now if I stack those, now I have the same circle, but I have 4 of them. So now I need to multiply that times 4. So the volume of the cylinder, base times height, Our base is 49 pi. Our height here is 4. 49 times 4 gives us 196 pi, and that would be units cubed. Area, remember, is units squared. In our last example, we still have the same circle, but now there are more of them, specifically a height of 11. So volume base times height is 49 pi times 11, giving us a total of 539 pi units cubed for our volume there. So the volume of a cylinder, exactly the same formula, base times height, but this time our base is pi r squared h. So for a cylinder, there's just a very specific formula for the base that we can use. Base is still the area of the base. So let's take a look at some cylinders. On number 1 here, we're trying to find the volume of a cylinder. We are given our bases that are circles. The height is the distance between those two bases, so it's 11. 12 is our diameter, so our radius is 6. We need to find the area of the base first. Base is pi r squared. Our radius is 6. So that leaves us 36 pi. Our units are feet. So the base is 36 pi square feet. But we're not after the base, we're after the volume, which is base times height. So that's 36 pi times 11, giving us a volume of 396 pi cubic feet. Because it's a volume, it is cubic feet. For number 2, we're doing something very similar. We have a cylinder here. How much soup does the can contain? So we're looking for volume. It has a diameter all the way across of 3 inches. That's our diameter. Immediately, I know I'm going to need to find the radius. Half of 3 is 1.5 inches. It has a height of 5 inches. Label the diagram. Did it? How much soup does the can contain? So first, let's find the area of the base. That's pi r squared. My radius is 1.5. That gives us 2.25 pi. Units are squared inches. But we're not after the base, we're after the volume, which is going to be base times height. 2.25 pi for the base times a height of 5, giving us a grand total of 11.25 pi cubic inches. For the next one, we're going to draw a diagram. We are not going to do 4. So for our last one for this section, again, we're drawing a diagram here. Find the volume of a cylinder. Cylinder means it's got the circles. With a radius of 4 yards and a height of 5 yards. Draw a picture and label it. Always draw a picture and label it. So first we want to find the base. This is a circle, so that's pi r squared. My radius is 4, so that's 16 pi square yards. Then we need to find the volume. Volume equals base times height. So that's 16 pi for the base and a height of 5. 16 times 5 gives us 80 pi cubic yards because it's volume. So that's the volume of prisms and cylinders. Our next step is to look at the related shapes, which are pyramids and cones. So let's take a look at section 5. In section 5, we're looking at the volume of pyramids and cones. Our objective is to find said volumes. So if you'll remember, a pyramid has the same base and it can have the same height as a prism, but it goes off to a point. So we can really fit each pyramid into a prism. And the relationship is going to be a 1-to-3 relationship. We'll talk about that in just a second, but that is the key, 1-to-3. So a pyramid, the volume of a pyramid is related to the volume of a prism with the same base and height. And we use the formula volume equals 1/3 base times height. A cone is related to a cylinder with the same base and height, and we'll use volume equals 1/3 base times height. And remember, we can substitute because we know the base is a circle, pi r squared times h if we want to. Same formula for both a cone and a pyramid, but we can be a little bit more specific for a cone because there's only one shape that base can be. So this is what I was talking about, that relationship of 1-to-3. Now, it's hard to visualize it. So there are 3 different colored pyramids here, and they're shaped so that you could see each of those pyramids, if they have the same volume, will fit together into a prism. It's very hard to visualize this. So if you have like an ice cream cone and a small glass that have approximately the same dimensions, what you could try is filling up that ice cream cone with water and seeing how many times it would fill the glass. And it will take 3 ice cream cones in order to fill a glass with the same dimensions, same base and the same height. Okay, so that's kind of how you can think of this. If you take a pyramid and you put 3 of them together, it will make a prism, or you can think of it as taking a prism and breaking it into 3 pieces will give you a pyramid. So that's the relationship 1-to-3. So let's look at some examples here. Find the shape of this. We're going to look at the base that has no connection to the vertex that all of the sides converge to. So our base is down here, and that is a square. Just like we were looking at in our last section, each of these lateral sides is congruent for a square base. So how do we find the height of the pyramid? The height, now last section we were mostly using slant height, which was if we slide down the outside of the pyramid. Let me grab my little pyramid here. So last class when we were finding surface area, we were using this sliding down the outside of the pyramid, which is the slant height. Now what we're using is if I were to put a hole in the top here and just fall straight down due to gravity, and that is the height. So if we're looking at from the base up to the top, what is that distance? Not along the side, but if I were to fall straight down through the top of the pyramid. That is the height of the pyramid. So our height here is 35 yards. To find the area of the base, I'm going to use the formulas from our previous chapters, and we're going to say the base is a square. The area of a square is base times height. 30 by 30 because it's a square. 30 times 30 is 900 square yards. But we're not after the base, we're after the volume, so we're going to use that in order to find our volume. Because this goes to a point, it doesn't have another side, this is a 1/3 formula. So 1/3 base times height, right? I can kind of imagine putting another one here and another one here in order to get a flatter top. And so that is a 1/3 base times height. 1/3 base was 900. Our height is 35. Put that into the calculator and we will find 10,500 cubic, because it's a volume, yards. Okay, we'd like to compare these volumes. We have 2 candles. We want to know which one has more wax. In order to find the area, or in order to find out how much wax, we need to find the volume of each of these shapes. I'd like you to go ahead and try finding the volumes. We'll go through it together and compare them. So our first candle here is a prism. I can say my base is 9 by 9, so it's a square prism, also known as a cube. And so I'm going to find the base, which is 9 times 9, That's 81 square centimeter base. To find the volume, it's flat on the top, so this is not a 1/3. This is a base times height. So that's 81 times 8, which gives us 648 cubic centimeters. For our other candle, we have still a square base, so a square, but this time it's a pyramid. It comes to a point, therefore it is a 1/3 formula. So our base to start with is just a square, 12 by 12, which is 144. It has a much larger base, but don't let that fool you. It doesn't mean anything about the volume. Our volume is now a 1/3 base times height. 1/3, our base was 144. Our height here is 11. Put all that into the calculator and we should get 528 cubic centimeters. So which candle has more wax? It is the pinkish purple one. It's the cube. The cube is greater than the pyramid. Okay, let's take a look at our last page. We want to find the volume of our solid. This one is a cone, comes to a point, and so that is going to be a 1/3 formula. First, we need to find the base. Always for these volumes, we're starting with the area of the base. So our base here is a circle. A circle is pi r squared. I am given, though, the diameter. So our radius is half of that, which is 3 yards. So our base is pi times 3 squared, or 9 pi square yards. Oop, I started to box that. That's not the final answer. That is just the base. In order to find the volume, we're going to do 1/3 base times height. That is 1/3, our base of 9 pi, times our height, dropped straight down from the top, is 9 yards. 1/3 times 9 should give us 27 pi. Volume is cubic yards. For number 2, we'll also find the volume. This is again a pyramid, so this is going to be a 1/3 formula. Our base is a square, so let's start with our base, which is 4 times 4, or 16 square inches. For the volume, we're going to use 1/3 base times height. That is 1/3. Our base is 16. Our height, we don't actually have it yet. This is the slant height. So in order to find the height of this pyramid, we need to create a little right triangle. So we know that the slant height is 6.3. This is the height that we're looking for. And our base here goes halfway across the square, so that is 2. To find the height, we're going to do the square root of our hypotenuse squared minus our side squared. Put that into the calculator, and we'll get approximately, I should put approximately symbols, 5.97. So we're going to round that to 6. It's very close to 6. And so our height here is 6. Where did this come from? It came directly from Pythagorean theorem. It's kind of the shortcut to the Pythagorean theorem that we've seen a couple of times. So now we can find the volume. 1/3 times 16 times 6 is 32 cubic inches. Okay. Number 3, we're looking at a cylinder here. So our cylinder, that's just a misprint. The cylinder has a diameter of 16 and a height of 6. We need, for circles, a radius, which is half of the diameter. So that will be 8. Our units here are centimeters. To find the area of the base, that is pi r squared. Pi times 8 squared is 64 pi. squared centimeters, but we're not just looking for the base, we're looking for the volume. This has two bases, so no 1/3. This is just base times height. That's 64 pi times our perpendicular, which is 6. 64 times 6 gives us 384 pi. Volume is cubic centimeters. And here we have a hexagonal prism and a hexagonal pyramid with the same base and height. We want to look at their relationship. So I'm going to attempt to draw this hexagonal prism. So I start by drawing a hexagon, and then I draw the other sides, dotted just because they're behind, so it gives you a sense of depth. So there's a hexagonal prism, and then a hexagonal pyramid. Something like this. They all go to a vertex. The back two will be hidden. Okay, so what's the relationship between these volumes? Well, this volume is going to be base times height, and this volume is going to be 1/3 base times height. So if they have the same base and height, then the prism is going to be 3 times the pyramid. Or we can say that the pyramid is 1/3 times the prism, which is really exactly what our formula tells us as well. Okay, our last examples here, we are not doing spheres. Spheres are tomorrow's lesson. So that will be for tomorrow, but we can do cones. So how much water would you need to fill up a cone-shaped vase for flowers? So here's our cone. This is the vertex. If the height of the vase is 30 centimeters and the radius is 12 centimeters, how do we find our volume? Well, always starting with the area of a base. Our base here is a circle, so pi r squared. Our radius is 12, so that gives us 144 pi centimeters. Area is squared. And then we're going to use that to find the volume. This goes off to a point instead of to a side, so that is a 1/3 formula. So that's 1/3. Our base was 144 pi. Our height is 30, giving us 1,440 pi cubic centimeters for the volume. Okay, and finally our last question here, which one would hold more water? I'd like you to try this one on your own, and then we'll go through it together. So part A, here we have a cylinder with a radius of 4 and a height of 6. So we need to find the area of the base. Our base is a circle, that's pi r squared. So that's pi times 4 squared, giving us 16 pi squared meters. But we don't want the base, we want the volume. Volume here, 2 bases, so no 1/3, just base times height. Our base is 16 pi times the height of 6, giving us a volume of 96 pi cubic meters. And we want to compare that to this here cone. So our cone, I'm going to do it on this side just so we can compare the process. Our cone has a radius of 6 and a height of 12. Our base is also a circle, pi r squared, with a radius of 6. So that's 36 pi squared meters. But just because it has a bigger base does not mean it has a bigger volume, because this is a cone. So our formula for volume is 1/3 base times height. That's 1/3 times our base of 36 pi times our height of 12 meters, because it drops straight down. And so if we put that into the calculator, we will find 144 cubic meters. And that gives us that the cone has a bigger volume. 144, pi is bigger than 96 pi. So the cone is bigger than the cylinder